This presentation is about speed time graphs. Grade E students will be able to sketch a speed time graph and description of motion. Grade C students will be able to use the gradient of speed time graph to find acceleration and the area under a speed time graph to find distance. Grade A students will be able to use speed time graphs to find unknowns. Section 3, Speed Time Graphs, of the M1, page 7 of the M1 booklet. This is an example of a speed time graph. In M1, we will only be dealing with a straight line speed time graphs. The gradient of the graph at any particular point is the acceleration. The area under the graph is the distance travelled. In this example, a cyclist leaves home O and rides along a straight road with a constant acceleration. So we're to draw a speed time graph of this. So after 15 seconds, he reaches point A with a speed of 10. And maintains this speed for 30 seconds. Now let's bear in mind that these graphs do not need to be to scale, they just need to have the pertinent information recorded. Then it returns uniformly to rest at the point C. The whole journey takes 70 seconds. We have our sketch. Now in part A, we're to find the acceleration from O to A. Now acceleration is the gradient of the graph. So the difference in y, which is 10, over the difference horizontally, which is 15. So 10 over 15 is 0.67 meters per second squared. Part B, retardation is negative acceleration, so we don't need the minus. The difference in y is 10. Let's say if it had been acceleration, we'd have had to put minus 10. Different horizontally from 45 to 70 is 25, so it's 10 over 25, which is 0.4 meters per second squared. Now in part C, we're to find the total distance travelled from the point O to the point C, so the total distance for the journey. Now we could do this by splitting up the area into 3 components, work out the first area of the triangle, the rectangle in the middle and the triangle at the end. The quickest way is to use the formula for the area of trapezium, which is a half times the distance between the 2 parallel sides. Well, bottom side and top side are parallel, distance between them is 10, times the 2 parallel sides, the lengths of those added together, so 70 for the bottom and 30 for the top. So a half times 10 times 100, which is 500 meters. Now as we've done it a different way, first triangle is 15 times 10 over 2, 75. Middle rectangle is 30 times 10, which is 300. And last triangle is 25 times 10 over 2. Add the 3 areas together, we again get 500. So either method is fine. In this example, a man is jogging along a straight road at a constant speed of 3 meters per second. So verbally we will need to draw a speed time graph. And then that is part A of the question. So the man is jogging at a constant speed of 3. So let's denote the man by M. Now he passes a friend with a bicycle standing on the side of the road 30 seconds later, so 30 seconds. The friend cycles to catch him up. Accelerates a uniform rate of 5 meters per second squared until it reaches a speed of 10 meters per second. then maintains a constant speed. It's a cyclist. We're to find the time that elapses before the cyclist reaches the jogger in part B. Now, in order to do part B, we're going to need to know what time the cyclist hits its top speed. Now, basically the gradient of that line is the acceleration, which is 5 meters per second squared. So at a 5 meters per second squared, it will take 2 seconds to hit a speed of 10 meters per second. So cyclist hits the top speed at 32 seconds. Now, the cyclist will reach the jogger when they've travelled the same amount of distance. The area under the curve for the man, the jogger, is a simple rectangle. It's 3 times the time, so we'll call that 3t. T for the amount of time. That's what we're going to try and find, the t. We also need a formula for the area under the cyclist's curve. Now we could do it again by splitting it into a triangle and a rectangle. However, we can use the formula for the area of trapezium, because we have got a trapezium. Very often trapeziums are used in this. So if we use the trapezium instead, it's half times the distance between the parallel sides, which is 10, times the 2 parallel sides added up. Now in this case we don't actually know how long the parallel sides are, because they are both in terms of t. But for the first one it will be t minus 30 for the bottom one, plus t minus 32 for the top. So simplifying, 3t equals half times 10 is 5, t plus t is 2t, minus 30 minus 32 is minus 64, that's minus 62, sorry, my error. Multiplying out, 3t equals 5 times 2t is 10t, 5 times 62 is 310. Take 3t from both sides, zero equals 7t minus 310. So 7t equals 310, t equals 310 divided by 7, whatever that gives us in the seconds. I've got a calculator to hand. So since I don't, obviously you can use the calculator in the exam. 7 into 31 goes in 4 times, into 3, goes into 30, 4 times, remainder 2. Something goes into 20 twice, remainder 6. 7 goes into 68 times. I don't care about the remainder here, it's just to get my rounding right, so it's 44.3 seconds to 3 significant figures. So obviously I recommend using an actual calculator.